Hi viewers, welcome to LMS Solution. Today we are going to see about solar PV battery driven electric vehicle by employing transformerless buck boost converter. This is a simulating model created for a solar PV battery driven electric vehicle. This system consists of solar panel. The solar panel rating is around 1830 watts at 25 degrees Celsius and 1000 watts per meter square. And single panel rating is 305 watts and open circuit voltage is 44.8 volt. The voltage at maximum power point is 35.59 and short circuit current is 8.85 and the maximum power point current is 8.57. Here we are using two series string and then three parallel string. It will be generate maximum of 1830 at a standard test condition. And then here we are using that transformerless buck boost converter. This is going to be used for extracting the maximum power from the PV panel along with the MPPT algorithm. This transformerless buck boost converter can operate in buck mode as well as boost mode according with the requirement in the output side. So this is structure of the transformerless buck boost converter. Normally we used buck converter or boost converter in between solar panel and the main DC bus or load side. Instead of we are using buck and boost, here we are using buck boost transformerless buck boost converter having the property of both buck and boost converter. So this transformerless buck boost converter is controlled by means of MPPT algorithm. So here we are used P&O MPPT. For P&O MPPT, we are providing PV voltage and current to generate the duty cycle. This duty cycle can be processed via pendulum generator and it will generate a pulse. This pulse will be given to here. This will control this transformerless buck boost converter to extract the maximum power from the PV panel according with the settings of irradiation and temperature. And here we are using battery. Here we are consider a 4 load battery and each battery having rating of 48 and then it's going to be connected via a bidirectional DC-DC converter. So this bidirectional DC-DC converter controlled by means of the DC bus voltage control, and when we are going to control the DC bus voltage, for that we have to measure the DC bus voltage. It when we compare with the 90 volt. We are comparing 90 volt. Here the PMDC motor going to act as a electric vehicle motor. The rating of this PMDC motor is 90 volt. That's why we are going to make the DC bus voltage 90 volt. This the DC bus voltage is going to be compared with the 90 volt and then processed by a PA controller. And the PA controller will be generated the duty cycle that going to be processed by a pendulum generator. This pendulum generator will generate the pulse for this 2 IGBT in order to control the current flow in this system. And also it will be maintain the voltage across this DC bus voltage around 90 volt. Here we are connected the PMDC motor going to be act as an electric vehicle. This motor will be powered from solar PV and battery. Is continuously getting power from the either PV or battery depends upon the irradiation and temperature condition. Here we have the measuring system measurement sections. Here we are measuring the PV voltage, current and power. Here we are measuring battery voltage, battery current and DC bus voltage. Here we are measuring speed of the BMD's motor, torque and the motor current. This is a simulating model explanation for the solar PV battery and driven electric vehicle. Now we can see the results. I'm going to simulate the result. Before that, I'm going to show you the settings of the irradiation. Here you can see that from 0 to 5, the irradiation maintained at 1000 watts. From 5 to 10, the irradiation will be maintained at 0.5. After 10 to 15, the irradiation will be maintained at 1000. That means 1000 watts per meter square. So 1500, 1000 watts per meter square. So it will be changed according to this timing. And also we are going to check the results of PV, battery, motor and then SOC of the battery. So I'm going to simulate this model. Now we can see that battery voltage around 70 volt and then PV voltage is around 70 volt and then PV current is around 25 amps and then we are getting around 1816 watts from the PV bar. That means it is nothing but the maximum power from the PV at 1000 watts per meter square and 25 degrees Celsius. And here you can see that this is the battery voltage that is around 50 volt and then this is battery current is negative. That means battery now charging mode and then DC bus voltage maintained around 90 volt. So here you can see that the SOC of the batteries keep on increasing because during the time from 0 to 5, PV having excess power. That's why the PV going to be supply the power to the load as well as that means BMDC motor as well as battery. After 5 seconds, you can see that the power is changed from 1860 to around 950 something. So here you can see that because of the power reduction in the PV, because of irradiation reduction, so what will happen? The battery comes to discharging mode. Here you can see that the battery current change from negative to positive. Here the battery will be supply the power to the BMDC motor, and also we are getting power from the PV also. Here you can see that the SOC of the battery is decreasing. Battery will be supplying the power to the PMDC motor. So we will check at 10 seconds. Now you can see that again the radiation changed to 1000 watts per meter square. Due to that, PV is generating maximum power around 1860 watts. Because of that, the battery now comes to charging mode. The battery current, here you can see that the battery current is comes to negative, and then here you can see that the battery SOCs keep on charging, and here you can see the speed of the motor is maintained around 1700 RPM. This is the torque of the machine. The torque of the machine is maintained constant. The motor current also maintained constant with any changes in the PV side. So the PMDC motor is always getting power from the either PV or the battery. So this is the working of solar PV battery driven electric vehicle with employing a transformerless buck boost converter. Thanks for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.